Okay, so today we look at the last subtopic for electronics. Okay, this is the final subtopic. We call it logic gate lah. Now, so logic gate basically is defined as electronic circuit with a single output. That means can only have one output, but can have one or more than one input lah. Okay, so one or more than one input. And then in logic gate, we uses 2 digit to express situation, which is 0 and 1 lah. So 0 meaning no input, no output. 1 means you got input or you got output lah. Okay. Now example, simplest example, let's say you have electrical circuit like this. Okay, so what will be the input? So the input in this case will be the switch. Okay, so the switch will become the input. Okay, so the switch will become the input lah. Now whereas the bulb will becomes the output. Okay, now so the switch, right, it can be in two condition lah, which is on or off. Okay, so if it is off means we state logic 0 lah, logic 0, that means there's no input. If it is 1, is on means logic 1 lah. So meaning this one is logic 0. Okay, this is logic 0. When I on, it becomes logic 1 lah. Okay, now same goes to the bulb. So the bulb also have two situation. Either it lights up, okay, or does not light up. Okay, does not light up. Okay, so if it lights up, that means what happened? Your logic will be logic 1. Doesn't light up, logic 0 lah. So this one means got output lah, got output. Okay, if I off, that means there's no output. Okay, so 0 means it can be you have input. Sorry, 0 means no input or no output. 1 means you have input or you have output lah. Yeah, so we use numbers to show the situation. Okay, so now for your syllabus, right, there is 3 basic logic gate that you must know. So we call it as the AND gate lah. Now, so AND gate, right, the simplest example will be the okay, a bulb with two switches, series to each other and a battery lah. So now in logic gate, actually we make a table, we call it the truth table. Now in the truth table, what we do is basically we list all the possible input and output we can get, all the possible input, all the possible output they can get. Now since you have only 2 input, okay, and then only 1 output, right? So there's 4 possibilities. The first situation, you off A, you off B. So if you off A, you off B, what happened? You see that the bulb cannot light up, so your logic will be 0. Okay, what happened if you on A but you off B? So still cannot light up, so logic 0 lah. Now next, if the third situation you okay, just now you off A on B, right? Now let's say you on A, you off B, so still the bulb doesn't light up. Now what happened if you on A and B? Okay, that means when you on this both, what happened? Then only the bulb lights up lah. Okay, this one we call it AND gate. Why? Because in order to get your output 1, both A and B must be on. Okay, both A and B must be on. So I call it AND gate. Okay, both A and B must be on. Okay, so any circuit, okay, that behave like this, okay, the general symbol for AND gate will be like this. So these are your 2 input. This will be your output lah. So the D shape is your is the symbol for AND gate, the D shape here. Yeah. Now example of everyday situation is example. Let's say if you want to use the ATM machine, let's say you want to go to the system of the bank. Okay, whether you want to transfer money or withdraw money or to look at your accounts, right? Okay, now at the ATM machine, you must have 2 input. One is the ATM card. Okay, so you have the ATM card. Okay. Okay, you must have the ATM card. And then the second thing that you must have is your PIN number. Okay, PIN number. Okay, so these 2 will be the input, and then your output will be the whether you can enter the system of the bank lah. Okay, the bank system. That means whether can you withdraw money, look at your account and so on lah. So the bank system lah. Okay, that means to look at your account. Okay, to look at your account. Now you see what happened here. Now let's say if you choose the wrong ATM card, and the wrong PIN number, what happens? You cannot enter the system. That means you cannot look at your account. If you have the correct ATM card but the wrong PIN number, okay, still you can't enter, okay, to look at your account. If you have the wrong ATM card but the correct PIN number, still you can't enter the system to view at your account, to view your account. But if you have the correct ATM card and the correct PIN number, then only you can enter the system. So we call it AND gate. Why? Because both system must be on, then only you can get your output. Okay. So these are some of the application. The circuit is a bit complicated, but it's like just a concept only. Okay. So now, what do you call it? AND gate also can be expressed in mathematical terms. We call it Boolean algebra. Now x equals to a dot b. A dot b means a times b. Now 0 times 0 give you 0. 0 times 1 give you 0. 1 times 0 give you 0. 1 times 1 give you 1. Okay. So let's say this is your input, right? 0, 0, 1, 0, 0, 1, and 1, 1. So when you times 0 times 0, 0. 1 times 0, 0. 0 times 1, 0. So 1 times 1 give you 1. Okay. So that means AND gate, what you must do, you must times. Okay, you must times. So what you must do is, what you must know is, you must know the circuit. You need to know the truth table. Okay, the symbol and Boolean algebra. Okay, this one actually you refer to the diagram. Okay, refer to the diagram. Okay, now the second logic gate will be the OR gate. Okay, now OR gate. So for OR gate, right? Okay, so what happened? The switches will be parallel to each other. Okay, so since you have two input, there's 4 possibilities. Now, first situation, you off A, you off B. If you off A, you off B, the bulb doesn't light up. So logic will be 0. Now, what happened if you off A, you on B? That means you on top, right? So you can see the current can flow, right? So what happened? The bulb will light up. Okay, next. Third situation, you on A, but you off B. So still can flow, right? So the bulb will still light up. Okay, what happened if you on A and B? So the current will flow here. It will split into 2. And then go back to negative. So still light up. Now, why we call it OR gate? Because of the second and third row. Okay, second and third row. Now, why we call it OR gate? Because in order to get output 1, at least A or B. That means at least 1 must be on. Okay, at least 1 must be on. So call it OR gate. At least 1. AND gate means both must be on. So OR gate means at least 1 must be on. Okay. Now, the symbol for OR gate will be like this. It's like okay, front of the arrow. Okay. So it's like an arrow shape here. Okay. So now the operation for AND gate, OR gate will be plus. So 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. Now 1 plus 1. Okay. Actually, this is base 2 because you're using 0 and 1. Now, if 1 plus 1 in base 10, you get 2. Okay. 2 actually is 1, 0. Okay. Because this 2 to the power 0, this 2 to the power 1. Okay, so we take the front one only. Okay, so 1 and 1 will be 1. Okay, so 1 and 1 will be 1. Okay, so that means OR gate at least 1 must be on. So let's say I have 0, 0, 1, 0, 0, 1, and 1, 1, right? So 0 plus 0, 0, 1 plus 1, 1, 0 plus 1, 1, 1. Okay, so get 0, 1, 1, 1. Okay, now next. The third basic logic gate you must know is NOT gate. Now, NOT gate only have 1 input. Okay, only have 1 input. So that means there's only 2 possibilities. Either you off A or you on A. Now, first situation, when you off A, right? Then what happened? The current will flow here. It goes to the bulb. The bulb will light up. So what happened? Your logic will be 1. So when this one is off, your bulb will light up. I mean, logic will be 1. What happened when you on A? Now, when you on A, the thing is now the current can pass through here and also go up. Okay, but the current majority will go here. Why? Because this part has offer less resistance. Okay, this part offer less resistance because there's no appliance there. There's no bulb. There's nothing there. It's just a connecting wire. So this part offer lesser resistance. So majority of the current will flow here. Okay, so it's something like no current flowing up here. So because of that, what happened? The bulb will not light up. So I call it short circuit. Short circuit. That means the current will flow here and then go back to negative. That's why the bulb doesn't light up. So what does the NOT gate do is it inverts your input. That means if your input is 1, output becomes 0. If your input is 0, output become 1. Okay. So basically, right, Okay. You need to know what is the operation of AND gate. So AND gate, okay, AND gate means what you must do, you must times or multiply lah. OR gate, you must plus. Okay. NOT gate, okay, you must inverse. Okay, so NOT gate, you must inverse. Okay.
Teacher, apa tu kan like AND gate, you give example like the ATM tu kan.
Yeah.
Kalau OR gate,
OR gate is something like you look at the door of the car, right? Any one of the car, the door is not, what do you call it? Not closed properly, right? You can see the indicator, right? At the dashboard.
oh,
Any
they
one.
got ask the teacher example of the gate all this.
Huh?
They got ask example lah.
No.
Okay.
Once you go higher level, they ask you lah.
Oh.
Okay, this one only the basic only. Okay, this is more on computer. You should know what you science computer, right? They use more in science computer lah. Okay, next. Okay, now NOR gate. Now NOR gate basically is a combination of NOR and OR. NOR and OR and NOT. Sorry. Okay, OR gate and NOT gate. Okay. Where's the NAND gate? Oh yeah, NAND gate first. Now NAND gate is a combination of AND and NOT. See what happened? Let's say if you have an AND gate, right? Okay, and then you have a NOT gate. Yeah. So let's say your input 0, 0, 1, 0, 0, 1, and 1, 1, right? So 0 times 0, 0, 1 times 0, 0, 0 times 1, 0, 1 times 1, 1, right? So when you pass to NOT gate, what happened? Inverse become 1, 1, 1, 0. Okay. So that means in NAND gate, what we do is, okay. So in NAND gate, what we do is we times and then followed by inverse. Okay. That means you have 0, 0. 0 times 0, 0, inverse become 1. 1 times 0, 0, inverse become 1. 0 times 1, 0, inverse become 1. 1 times 1, you get 1, inverse become 0. Okay. So the symbol for NAND gate is something like AND gate, only thing that's circle here lah. Let me just remember you inverse. And then in terms of Boolean algebra, x equals to a dot b bar. Bar sign is the inverse lah. Okay. Bar sign is the inverse. Okay. And then the last one will be the NOR gate. Okay. Now for NOR gate, is a combination of OR and NOT. So let's say if you have an OR gate, and then in front there you put a NOT gate. Okay, so 0, 0, 0, 1, 1, 0, 1, 1. So 0 plus 0, you get 0, 0, 0, 1, 1, 1, right? Okay, 0, 1, 1, 1. So when it comes to inverse become 1, 0, 0, 0. Okay, so NOR gate, what you must do is you must plus and inverse. Okay, plus, inverse. Okay. Okay now. Okay, so there is only 5. Other than that, it's not in your syllabus. Okay, 3 basic logic gate, and then okay, 2 combination, which is NOR and NAND. So NAND is AND and NOT. Okay, OR means is OR and what do you call it? NOT lah. Okay. Now, this one actually is related to your maths. Hello. 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 Okay. Okay, so is that means what you do is, right, in NAND gate, right? It's like you take the AND gate, you put inside the NOT gate. Okay, you put the AND gate, you take the AND gate, you put inside the NOT gate. It's like if you do function, right? FGX, right? You do composite function, right? Correct. So let's say fx is 3x plus 5, right? And then let's say gx is 6x, let's say. So if you want to find the composite of fgx, what you do is you take the g, you put inside the f, right? That means you take this one, you put inside here, right? Correct. You take the g, put inside the f. So same goes to NAND gate. That means you take the AND gate, you put inside the NOT gate. Okay, it's related to your, it's max. Okay, so you take the AND, you put inside the NOT. Okay, same goes to NOR gate. Okay, you take the OR, put inside the NOT. Okay, so you take the OR, you put inside the NOT. Okay, now, now we look at example of question. Now this usually comes out in objective question. Objective question, usually they give you the symbol. They ask you to find what is your output. Example. Now, figure shows a logic gate P and Q. Okay, P, this is the input, Q is the input. What is the output of X? So what you must do is you must write the number lah. 0, 0, 1, 1, 0, 1, 0. And then this one is 1, 1, 0, 0, 0, 1, 1. Write the numbers on the diagram. Next, you need to know what is the logic gate here. So this is NAND gate. Okay, and then you must know what you must do with NAND gate lah. So NAND gate, you must times the operation. So times followed by inverse. Okay, so 0 times 1, 0, inverse become 1. 0 times 1, 0, inverse become 1. 1 times 0, 0, inverse become 1. 1 times 0, 0, inverse become 1. 0 times 0, inverse become 1. Okay, 1 times 1 is 1, inverse becomes 0. 0 times 1, 0, inverse become 1.
Sir.
Yeah.
The numbers they will give.
Yeah.
Okay.
Okay. Example like this, right? Okay, they give you the input like this, right? What is the output? So what you do is, okay, what you do is you write the order of the numbers in the diagram. So 0, 1, 0, 1. And then this one is 0, 0, 1, 1. Right. So it passes to AND gate, AND gate. So AND gate, what you must do, you must time 0 times 0, 0. 0 times 1 times 0, 0. 0 times 1, 0. 1 times 1 is 1. Now at the same time, this Q also goes down here. So this Q becomes the input of the NOT gate. So what you must do, you must inverse lah. So 0 inverse become 1, 1, 0, 0. Okay. So next, what is it? This is NOR gate. So NOR gate means what you must do, you must plus followed by inverse. Plus inverse, plus inverse. So 0 plus 1 give me 1, but I inverse become 0 lah. 0 plus 1 give me 1, inverse become 0. 0 plus 0, inverse become 1. 1 plus 0, 1, inverse become 0. Then you write the number, the order 0, 0, 1, 0. Okay. So this is the question that usually comes out in objective lah. Okay. So, okay, one more example. Let's say they give you like this. Okay, diagram shows the logic gate circuit. So complete the table. So what do you do again? Write the order of the number in the
bahwa Al-Quran bukan
0, 1, 0, 1. 0, 0, 1, 1, right? So this is AND gate. So you have to times. So 0 times 0, 0. 1 times 0, 0. 0 times 1, 0. 1 times 1, 1. And then you inverse lah. It becomes 1, 1, 1, 0. Okay. And then at the same time, it passes to NAND gate. Okay. See NAND gate. So it goes down here. So it become as the input for the NAND gate. So NAND gate, you just times inverse. Times inverse. So 0 times 0, 0. Inverse become 1. 1 times 0, 0. Inverse become 1. 0 times 1, 0. Inverse become 1. 1 times 1, 1. Inverse become 0. Then this one is the OR gate. So OR gate, you just plus lah. So 1 and 1 is 1. 1 and 1 is 1. 1 and 1 is 1. 0 and 0, 0. Okay. That means for OR gate, at least 1 must be 1. Then you can on. You can on. Okay. AND gate, both must be 1. Okay. So then you write here 1, 1, 1, 0. Okay. Now, Okay, let's see, right? We look at number 9 lah. Okay, diagram shows a circuit containing 3 logic gates. Okay, this one, I'm talking about this question. The others are similar lah. Now, which of the following is the correct? This one is your objective question. If you look at the answers A, B, C, D, right? All the order of P, Q is the same. 0, 0, 1, 1, 0, 1, 1, same, right? Order of Q same. So what you do, you just write the order here, 0, 0, 1, 1. And then 0, 1, 0, 1, right? Okay, for Q lah. Okay, now you see, right? For Q, right? Okay, it becomes the input for the NAND gate and also becomes the input for NOT gate. So if it goes down here, it goes to the NOT gate, right? So inverse becomes 1, 0, 1, 0. 0 becomes 1, 1 becomes 0. Okay, so 0 becomes 1, 1 becomes 0. At the same time, combine with P to become the output of this. So 0 times 0, 0, inverse become 1. 0 times 1, 0, inverse become 1. 1 times 0, 0, inverse become 1. 1 times 1 is 1, inverse become 0. Okay, and then is the output for AND gate here. So 1 times 1, you get 1. 1 times 0, you get 0. 1 times 1, you get 1. 0 times 0, 0. Okay, so that means your answer will be 1, 0, 1, 0. Okay, so 1, 0, 1, 0. So that means you need to know the symbol. What does it do? Okay, what operation? Okay, now what happen is sometimes instead of giving numbers, right, they give you in the form of graph like this. Okay lah, I take this one, number 14, right? Now they give you in the form of graph. So this one also same lah. Okay, this one means low. That means one is 0. This is 1. This is 0. This is 1. Okay, this is 1. Okay, this is 0. This is 0. This is 1. Okay, so okay, you see, right? This one goes here and at the same time go down here. So what happens when it goes down here? It passes through a NOT gate. So NOT gate is just inverse only. So 1 becomes 0. 0 becomes 1. 0 becomes 1. 1 becomes 0. Now, at the same time, it also goes to NAND gate. So NAND gate, you have to times, then you inverse. So 0 times 1, 1. 0 times 1, 0, inverse become 1. 1 times 0, 0, inverse become 1. 0 times 0, 0, inverse become 1. 1 times 1, 1, inverse become 0. And then it passes through the OR gate. So OR gate, that means at least 1 must be on, right? So 1, 0, you get 1. 1 and 1 also you get 1. 1 and 1 you get 1. 0, 0, you get 0. So that means it's 1, 1, 1, 0. Okay, see lah. So it's basically it's in the form of graph. Same only. Okay, same only. Okay, yeah. So basically, this is how your objective question will look like. Now, what I more like to discuss more is the object structured question, because this one involve application. Okay, it involves application. Now, example. Now, diagram 7.1 shows a sensor board which consists of a transmitter device and a sensor device that controls automatic sliding door of a shopping complex. So when a customer walks into the shopping complex, the sliding door opens automatically lah. So diagram 7.2 shows the circuit which contains the logic gate circuit that is connected to the electric motor that controls the sliding door. Okay. Now, table 7.1 shows the key to all situation. So they said transmitter on logic 1, off logic 0. Customer present logic 1, customer absent logic 0. Electric motor activated logic 1, electric motor not activated logic 0. So what is meant by logic gate lah? So this answer lah. Electronic circuit with single output but can have one or more than one input. Okay. So electronic circuit with one or more than one input but only one output. Okay. One or more than one input but only one output lah. Okay. Now next. Table 7.2. It's a truth table which shows the operation of the logic gate, the sliding door motor control system. So using the key in table 7.1, complete table 7.2. Okay. So output X would be the, what they call it, the sliding door lah, sliding door. Now, the first situation, they say transmitter 0 and sensor 0. So when transmitter 0, sensor 0, that means transmitter off, sensor off, that means the door will not be open. Okay. Transmitter off, sensor 1, the door will not be open. transmitter 1, sensor 0, it won't be open. When the transmitter 1, the sensor 1, then only the door will be open. Okay. Now, it's like this lah. Huh? So what happened is, okay, see, you on the transmitter, right? Okay, let's say there's a customer here. So what happened? The customer will reflect the signal to the sensor. So when the transmitter 1, sensor 1, the door will be open. Now, let's say what happened if the transmitter on but there's no customer. So the signal will reach the floor and then reflected but doesn't touch the sensor. Okay, doesn't touch the sensor. So what happened? Here 1, here 0. That's why the door doesn't open. But how come we can get situation where this one is 0, this is 1? Correct. So maybe the customer bring its own laser pointer, directs towards the sensor. Okay, hoping that the door will open. Okay, but it will not be open because the transmitter is not on. Okay, so from here we already know what type of logic gate lah. So AND gate. Okay, so your answer will be AND gate. So then they ask you to draw the symbol of AND gate lah. So the AND gate, the symbol will be like this. Okay, this symbol of AND gate. Okay. Next, the sliding door in diagram 7.1 takes a long time to open automatically. So some modification need to be done on the sliding door and the electric motor to enable the system the sliding door to open in a shorter time. State the suitable modification and give reason. So the mass of the sliding door, so mass must be small. Okay, so reason because it is lighter. Okay, so power of the electric motor, the power must be high lah. Okay, because you can say produce bigger force to open the door. Okay, or to open the door faster, but because they got shorter time, right? Okay, see that because when you have a high power motor, then it can produce bigger force to open the door. Okay, or more energy produced to open the door, so can. Okay. Now 16, this is also a partial question. Now diagram below shows a combination of logic gate to control a security lamp of 240 volt. So name logic gate P. So P comes under NOT gate. Okay. Now Q is an AND gate. Okay. Using the electrical component shown below, draw a circuit diagram which produces the same as Q. That means you have to draw the what they call it, symbol of the circuit for AND gate. So they give you all this already. So first, let's say I draw the battery. Okay. So the two switches, so make sure they are series to each other.
Sir, bateri memang lukis macam tu ke sir?
Ya, bergantung pada simbol lah.
Oh.
Dia sudah bagi macam ni, lukis lah macam ni. Aduh. Okay, next. Table below shows the okay, you're supposed to complete, right? So what you do is, okay, see, just write the order 0, 0, 1, 1. So just write ini here, follow ni. So 0, 0, 1, 1. And then this one is 0, 1, 0, 1. This one have to go to NOT gate. So NOT gate you have to inverse lah. So 1, 1, 0, 0. And then this one will combine with this to become the output of X. So 1 times 0, 0, and gate. 1 times 1 is 1. 0 times 0 you get 0. 0 times 1 you get 0. So just write lah. So 0, 1, 0, 0. Okay, that means you write the numbers on the, what they call it, write the numbers on the diagram. Okay, write the numbers on the diagram. Okay. Okay, yeah. Next. So now state one function of the relay switch. So what function of the relay switch? Okay, yeah. Now, so what is the function of relay switch? Okay, now this circuit actually is not clear because they put in boxes lah. I'm going to refer back to this circuit. Okay, the same one here. You see why there's a relay switch here. Okay, why I cannot put the motor directly here? Okay, why I can't bring the motor directly here? Now you see, right, the motor uses higher voltage. This logic gate circuit here can only give you maximum 12 volt. So if your output is 1, okay, if your output is 1, okay, that means there's current flowing, the motor will still not work because maximum voltage can supply 12 volt. That means the motor need a circuit by its own, a power supply by its own, that means higher voltage lah. So basically this is a, what they call it, relay switch. Relay switch, basically you have a coil here, okay, a coil here. You use the concept of electromagnet. That means when current passes through the coil, what happens? It becomes electromagnet, it will pull the switch. So it will on. Okay, this one will get on lah. But if there's no current, what happens? Uses magnetism, this one will be open. Okay, so relay switch is required because we want to switch on circuit that uses higher voltage. Okay, to switch on circuit that uses high voltage. Okay, so now, so they ask you what is the function of the relay switch, right? So the answer will be to switch on and off circuit that uses high voltage. Okay, to switch on circuit that uses high voltage. Okay, yeah. Now you must have the word high voltage. You see, any switch, the function is to switch on, switch off. But when you talk about relay switch, it must, okay, switch on, switch off circuit that uses high voltage. Okay. 17. Now Ali wishes to design a security system in his house as shown in figure A. When a person crosses the infrared beam at night, the infrared sensor will send signal to a logic gate which then lights up a spotlight. The spotlight at the 240 volt alternating current supply and will only light up at night. See, what happened is, they say, right, the spotlight, okay, will light up only at night. See, when a person crosses the infrared beam at night, the infrared sensor will send signal to logic gate which lights up the spotlight. So basically, like this, right, there's a person here. So there's a transmitter, there's a sensor lah, correct. So when the person walk, what happened? It will block the signal from reaching the sensor. So automatically the spotlight will be on lah, but at night. Okay, at night lah, daytime on it. Okay, daytime on it. So that means from here we already know what is the possible logic gate because it must be at night and there must be person crossing. Okay, it must be at night and then person crossing. Okay, so so the circuit shown below. Now, if the potential difference across W is 2 volt, what is the potential difference across the infrared sensor? So you see, this one is only 1 mark actually, right? You see, the whole thing is 12 volt. Okay, that means from here to here 12 volt. That means if W take 2 volt, that means the balance here will be 10 volt lah, because total is 12 volt. So here will be 10 volt. Okay, now component X has a high resistance when dark, low resistance when bright. So what is the resistance? So this is LDR, light dependent resistor. Okay, and then component S is a switch that connects the 240 volt AC spotlight. So what type of switch lah? So this is a relay switch. Okay. Now, why component S is necessary? Why we need that? That means why we don't put the spotlight here? Because the spotlight uses higher voltage. Okay. So spotlight uses higher voltage. Okay. Next. Now D, the following truth table shows the operation of a logic gate in the circuit in figure B. So they say when the surrounding is dark, the logic at P is 1. When the surrounding is bright, logic is 0. Okay, when there's a person crossing the path, logic will be 1. When nobody crossing, logic will be 0. Huh? Switch S is on, 1. Switch S is off, 0 lah. So here. Okay. So okay, when bright, nobody crossing, so the bulb will not light up. Okay. When bright, just 0. Okay. But there's person crossing, so 1 lah. Huh? So bulb no need to light up. When dark, logic 1, but nobody is crossing, so 0. Still your output will be 0. Huh? So no point for you to light up the spotlight. Okay, when it's dark, then there's a person crossing, then only 1 here. Okay, so this one is a AND gate. And then they ask you to sketch the symbol. So this will be a symbol of AND gate. Okay. Okay. Okay, yeah. Now we look at example of another also passive question, right? Now a factory producing pesticide uses a logic gate system to ensure, right, the volume of pesticide in the bottle is within acceptable range. Figure 8.1 shows the arrangement of the logic gate system fixed beside a conveyor belt carrying bottles of pesticide. So the radioactive detectors S1, S2 detects the level of radiation passing to the bottles lah. Okay, yeah? So detector S1, S2 will be given input 0 to the logic gate system when they receive low level of radiation. Detector S1, S2 will give input 1 to the logic gate system when they receive high level of radiation. See, it's like this. There's 2 radioactive source here. Okay. Now let's say this is the acceptable volume that we want. We want this. So what happens is, you see, the top one, right? The radiation will pass through the bottle without passing to the liquid. So that means no absorption by the liquid. So what happens? The input here will get a very high reading, but the bottom one will get a low reading. Why? Because the radiation will pass through liquid, absorbed by liquid. So low level of radiation detected. Okay. So that means this one is what we want now. Okay. What happens if the volume is too high? Let's say the volume is here. So when the volume is too high, what happens? So the radiation here, right, have to pass through the liquid. So it will be absorbed by the liquid. So what happens? Both S1, S2 will give you low level of radiation. That's what we mean. State the level of pesticide if the bottle, in the bottle, if the input S1 is 0. That means if S1 is 0, that means your level is more than the acceptable range. Okay, more than acceptable range. Okay, that means your volume is smaller. Okay, so that means, okay, volume is more than acceptable range. Okay, so reason, okay, because S1 detect low level of radiation. Okay, low level of radiation. Okay, next. State the level of pesticide if the input S2 is 1. Now what happened? Okay, what happened if the volume is low? Let's say, right, the liquid here is this much. So what happened? Both radiation, right, will pass through the bottle without passing the liquid. What happened? That means S1 and S2 will give you high reading. Because why? They pass through without going through the liquid. Okay, that means S1, S2 will record a very high reading. Okay, that means we know that the volume is less. So here, right? So that means volume is less than acceptable range. Okay. So reason because S2 detect high level of radiation. Okay, radiation. Okay. Next. Figure 8.2 shows two combination of logic gates P and Q that are suggested to develop the logic gate system. So state logic gate M. M is OR gate lah. So M is OR gate. Okay, so OR gate. Okay, OR gate. Next. Now, complete the truth table for P and Q. Complete the table for P and Q. Okay, this one you see, right? They already give you the number 0, 1, 1, 1. 0, 0, 1, 1. Same, right? Okay, same. Okay, same. So what you do is you just write this value on the diagram. So 0, 1, 1, 0, 0, 1. Same goes here. 0, 1, 1, 0, 0, 1, right? Okay. So what happened? This one have to pass through AND gate. So 0 becomes 1. Sorry, not gate. So 0 becomes 1. 1 becomes 0. Okay. So 0 times 1, 0. 1 times 1, 1. So 1 times 0, 0. Okay. And then for this, here become 1, 1, 0, right? Okay. So OR gate, either one of you on. So 0 and 1 will give you 1. 1 and 1 also give you 1. 1 and 0 also give you 1. So this one is 0, 0, 1. This one is 1, 1, 1. So 0, 1, 0, 1, 1. Okay, 1, 1, 1. Next, they ask you, okay, when the output of the logic gate is 1, it indicates the volume of pesticide is within acceptable range. When the output is 0, it indicates the volume is outside acceptable range. So based on this one, which combination is suitable? You see. So when they say when your output is 0, right, that means it's outside. Outside means it can be too high or too low. Okay, when it's 1, that means acceptable range. You see, this one, right? And this one, okay, what do you mean by S1, S2, 0? So when S1, S2, 0, that means what happen is your volume is very high. Correct. This one 0, this one 0. So by right, it's supposed to reject. It's supposed to become 0 also lah. We cannot accept. Okay, we can't accept. Okay. Now, same thing, what happened if it's too low? If it is too low, that means what happened? This one becomes 1, this one becomes 1. Okay, that means because both will detect high level radiation. That means your output must become 0 also. We have to reject. Only acceptable range we can accept. Others we have to reject. So from here, what we can see is the first one here, okay, if it is too high or too low, the level is too high or too low, it is rejected. But this one, no, right? It's too high and too low, output is still 1, that means you still accept. So cannot lah. Okay, so the suitable one will be P. Okay, the suitable one will be P. Okay, so reason we can say so when the level of pesticide is outside acceptable range, okay, output logic is 0. Okay, so when the level of pesticide is outside, we use the word outside. Outside means it can be too high or too low. If not, if you want to write, if it is too high, too low, the logic is 0 also again. Okay, So when the level of pesticide is outside acceptable range, the logic is 0. Okay, and then when the level of pesticide is within within acceptable range, the logic is 1. Okay, so when the level of pesticide is within acceptable range, the logic is 1. Okay, so get 2 marks lah. Okay, so that's why it's 2 marks. Okay, so the level is outside, logic is 0. Level is within acceptable range, logic is 1. Okay. Okay, now this also is a passive question. Now, a student wants to build a simple lift motor control system which operates using 2 buttons A and B. Okay, for a 2-story building. A is up, B is down. The lift motor only activates when someone presses any one of the buttons. Figure A shows the circuit that can be used to activate the motor. So they give you, okay, A and B, right? When press logic 1, not press logic 0. Okay, motor activated logic 1, motor not activated logic 0. So the table is the truth table which shows the operation of the logic gate in a lift motor. Using the key given, complete the table. Okay, so that means, right? Okay, they said the lift motor only activated when someone presses any one of the buttons. So anyone, we already know already lah. That means if you don't press 0, 0, it becomes 0. 0, 1 becomes 1. 1, 0 becomes 1. 1, 1 becomes 1. Okay. And then they ask you why relay switch is required. Okay, why here? Okay, so same thing lah. Because the motor uses higher voltage. Okay, next. Okay, now what happened is this one, they combine with, sometimes they combine with transistor. Okay, so the door of the lift is fitted with a light transmitter and a detector which is a light dependent resistor. So if the light dependent resistor detects light, the relay switch is activated and the lift door will close. So figure B shows an electronic circuit for the control system of the lift. So strategy between the resistance and the intensity of the light received by the light dependent resistor lah. Okay, so you can say lah, so when bright, resistance is low. Okay, when bright, resistance is low, or when dark, resistance is high, up to you lah. And then they ask you to complete, okay, by putting the, okay, putting the components into the diagram. Now they said what happened is, so when the detector, okay, so you see when you detect light, the relay switch is activated. That means what we want is when bright on. That means when bright, we want the circuit to on. Okay, when bright, we want the circuit to on. Okay, usually, right? Usually for LDR, when dark, we want it to be on. Correct. So that means we have to put down if dark. If dark, we want to on. That means LDR, right? So usually what we do, we choose L, right? We put low here, right? But this one is opposite. We want it to bright to on. So that means the LDR must be on top. Okay. So that means the LDR must be on top. The resistor must be down here. Okay. Usually for LDR, when dark, we want it to be on. But this one is a different case lah. Okay. This one, they bright, they want to be on. So you put on top. Okay. So what is that? So explain how the circuit function. So this one is only 2 marks. So okay, very simple. You just say okay, when bright, okay, resistance of LDR is low. Okay, so because of that, there is base current and collector current. Okay, so very simple. For transistor, they say why is on, you must have the keyword, got base current, got collector current. Get 2 marks already. Okay. Okay, okay, this one more passive question. Now, a student designed an electronic control system to switch on a fan in a classroom automatically. So diagram 3.1 shows the block diagram of the system that contains temperature sensor, light sensor, and logic gate. So name logic gate X, so X become AND gate. Okay, AND gate, AND gate. Okay, next. Okay, so table 1 is a table. Okay, so they ask you to complete the table lah. Okay, complete the table. Okay, so low, high, so low means 0 lah. So 0, 0, 1, 1, 0, 1, 0, 1. Okay, so 0, 1, 1, 1, 0, 1, 0, 1. So AND gate you times 0 times 0, 0, 1 times 0, 1, 0 times 1, 0, 1 times 1, 1. Okay, sorry. You're supposed to be 0. So 0, 0, 1, 1, 0, 1, 0, 1, right? So get 0, 0, 0, 1. Okay, 0, 0, 1. Okay. Okay, so 0, 0, 0, 1. So answer will be 0, 0, 0, 1. Okay. Okay, so this past year question also they combine with transistor. Okay, they combine with transistor. Now diagram 3.2 shows the circuit of the electronic control system. So when the light is detected by LDR, the resistance of LDR is 100. So resistance of LDR is 100 ohm. Okay, so state the potential difference across Y to Z. Now the whole thing is 6 volt. So from Y to Z also will be 6 volt. Okay, and then they ask you calculate potential difference across the LDR. Okay, so this one we can use the ratio method, right? Now you see, right, from here to here, the total resistance will be 100 plus 3,300. So that means 3,400 ohm is 6 volt. That means if it is only 100 ohm, okay, okay, so how much? So use the ratio method lah. So 100 divide with 3,400 times 6. Okay, 100 over 3,400 times 6. Okay, 100 over 3,400 times 6. Okay, so you get the answer lah. Okay, so your answer been good. Okay, now the last example. Okay, all these are application question. Now a bank has an alarm system which can be triggered by the cashier who work behind the counter. So the alarm can be triggered in 2 methods lah. So the cashier presses a foot switch, or the cashier remove an imitation $20 note from the cash drawer. So either there's a switch there, you just press using your foot, or you take out your imitation $20 note. Okay, a circuit inside the drawer contains an LED which is directed at an LDR as shown. So when the cashier remove the imitation note, the alarm will be triggered. So it's something like this. Okay, so what happens is there's a note. Okay, this one is a fake one lah. So what happens is when the note is here, that means the signal from the LED cannot reach the LDR. But the moment you remove this note, what happens? The signal from the LED can reaches the LDR. So automatically the thing will be triggered. Okay, so this one is a smarter way lah. Because when you press, people will know. But when you remove, because you have to remove the money, so the moment you remove everything, then you have the alarm automatically to be triggered. Okay, so underline the correct answer to complete the following sentence lah. So resistance of LDR, okay, decreases with intensity of light, decreases. Okay, next. Now part of the cash drawer circuit is shown below. So when the imitation 20 node is removed from the drawer, the voltage across the LDR will be 0.36 volt. Okay, 0.36 volt. And the resistance is 2 kilo ohm. So they ask you what is the voltage here. So same thing lah, use the ratio method. So if 2 kilo ohm is equivalent to 0.36 volt, that means if you have 48 kilo ohm, what is the voltage? So 48 divided by 2 times 0.36. Okay, so 48 divided by 2 times 0.36. So you get 8.64 volt. Okay, 8.64. Okay, yeah. Next. Part of the control system of the alarm is shown below. Okay. So complete the two table from the logic gate for level W and X. Okay, there's no W actually. It's just X. Okay. Okay, so here, right, when the imitation 20 is present, logic 1, remove logic 0. So remove means 0. You just follow only, follow this one. Remove 0, present 1, present 1. Okay. Not press logic 0. So don't press 0 when you press logic 1. So, okay, just follow this one, the key given here. Okay, now how about the X? Okay, when you remove, but you don't press, so the alarm must be triggered. Okay, alarm must be triggered, right? Because they say either one. Either you take out the node or you press the, must be triggered. Okay, it is removed, but press, also triggered. Okay, the imitation node is present, that means we did not remove, and then it doesn't press, that means 0 lah. Okay, the node is present, but we press the foot switch, so on. Okay, okay. So actually, it's guided already because they said, okay, the alarm can be triggered two methods. Either you press the foot switch or you remove the node. Okay, or both also can lah. Okay, now the question here: what effect does removing the NOT gate from the control system have on the operation of the alarm? Now, what happened if we remove the NOT gate? What happened to the alarm system? Okay, so now we remove this one, right? Let's say we remove the NOT gate. Okay. Okay, when you remove the NOT gate, you see, the number here is 0, 0, 1, 1. Follow this order, right? This is 0, 1, 0, 1. This is OR gate, right? OR gate, at least 1 must be on. So 0, 0 becomes 0, 0, 1 becomes 1, 1 and 1 becomes 1, 1 and 1 here also becomes 1. So what happened? Your output now going to become 0, 1, 1, 1. Okay, which is same? This is still same, right? With the NOT gate, so we don't talk about this. This also still same as the NOT gate. We don't talk about this. So what we need to talk is we have to talk about the first one or the third one. See, what's going to happen now is, okay, if you remove the $20 note, but you don't press, the alarm will not be triggered. So it's not good lah. Because before this, the alarm is triggered, but now the alarm will not be triggered. Or, okay, when you don't take out the note, you don't press the switch, foot switch, right? By right, supposed to be off, right? But without the NOT gate, it's on already. Okay, so that means you can choose either one lah. Okay, that means your answer can be like this. So when the imitation node is removed and the foot switch is pressed, alarm will be triggered. Alarm will be on or whatever lah. Alarm will be on. Okay, that means we are talking about the first one lah. Or you can even say, okay, either you choose this one or you choose the third one. Okay. When the imitation node is present or not removed lah, and the foot switch is not pressed, okay, alarm will be on or will be triggered. Okay, that's why we need a NOT gate there. Okay, so without the NOT gate, what happened? We have this odd situation lah. The second and fourth one is okay because it still follows the previous one. Okay, that means if you remove, it's still on, or if you press and remove the node, it's still on lah. It's still okay. But the one which is odd is will be the first one and the third one. Okay, it's not doing what we want it to do lah, because we want it to be if the node is still there, we don't press, alarm should not be triggered. Okay, but if we remove, we don't press, alarm supposed to be triggered, but it doesn't get here. Okay, so these are the question lah. Okay, so these usually they involve application question. Okay, but actually we look at it, it's all guided. Okay, it's a guided kind of question. Okay, they already tell you what is going on. Okay, you just need to think a bit more lah. Okay, like this one, right? What happened when you remove? So we know lah, this is going to happen. That means we take, when I remove the node, I don't press, I don't get the alarm to be on. Or when the node is still present, I don't press, the alarm suddenly triggered. Okay,